This is Pre-Calculus Part 1, Section 4.2, Trig Functions, the Unit Circle, on page 483, Example 6, using the Pythagorean identity. Okay. If you know that the sine is 3/5, and you know that the angle is between 0 and pi over 2, which means it's in the first quadrant, okay, instead of drawing the triangle, which you could still do, but it's the same idea, the Pythagorean theorem says the two sides, x squared plus y squared, should equal 1, because our hypotenuse is 1 in the unit circle. That's why it's called the unit circle, and 1 squared is still 1. So our sine is our y value, so that's 3/5 squared plus cosine squared, which is our x value, should equal 1. So 3/5 squared is 9/25. If I subtract that from the other side, 1 is 25 over 25, minus 9 over 25, that's where the 16 comes from. And then that's still cosine squared, so we have to take the square root of it, and we get 4/5. Normally when you take a square root, you have to do plus and minus, but because we know that we are in the first quadrant, we know it has to be positive. So we don't have to worry about the negative. But you're going to have to think about that at this point, whether it should be positive or negative or both, depending on if it just says on the circle. It could be either. The checkpoint says the sine is 1/2. So again, we're going to put that into the Pythagorean identity. X squared plus y squared equals r squared, where r is 1. So 1/2 squared is 1/4. Subtract that. 1 is the same as 4/4, so we're left with 3/4. And we take the square root of both sides, and I apologize, that should be a 2. And that should be a 2. Sorry about that. I forgot to square root the denominator. So you can either draw the triangle and solve for the missing side, or if you can use the Pythagorean theorem, which helps if you have your calculator available. This is very quickly done on a calculator.